5 billion years ago, the universe was still nothing more than the chaos left behind after the sun's birth. Fast forward through the rushing river of time, and we witness gravity working its magic. It gathered scattered dust into tiny rocky clumps. These clumps collided, stuck together, and slowly grew over countless ages. After tens of millions of years of accumulation, a miracle happened. About 4.54 billion years ago, the proto-Earth was born, but it was nothing like the blue haven we know today. At first glance, this newborn planet looked like a hellscape. Its surface temperature soared beyond 1,200 degrees Celsius. There was no breathable air, only suffocating carbon dioxide, nitrogen, and water vapor. Its scorching heat and toxic gases could incinerate and choke anything that dared approach. The Earth itself was a boiling sphere of molten rock, with hardly any solid surface. Even worse, it was still in the midst of violent bombardments. Disaster struck. A young planet, roughly the size of Mars, came hurtling toward Earth at an astonishing 15 kilometers per second. Its immense gravity twisted and tore at Earth's surface. Shockwaves swept across the entire globe in an instant. The collision was so violent that both worlds seemed to melt into liquid. The impact unleashed unimaginable power, hurling trillions of tons of rock debris into space. And yet, gravity once again revealed its wonder. Within just 1,000 years, these scattered fragments came back together, orbiting Earth, to form a blazing ring of dust and molten rock. From that ring, the newborn moon began to coalesce. It was about 3,500 kilometers in diameter, and only 22,500 kilometers away from Earth. A stone's throw compared to today's distance of 400,000 kilometers. On Earth's still cooling surface, the sun had just risen, but only 3 hours later, it plunged back beneath the horizon. The colossal impact had sped up Earth's rotation, so a day lasted barely 6 hours. Around 3.9 billion years ago, meteors continued to bombard the young Earth. They looked like grains of salt, but inside, they carried droplets of water. Those droplets may have contained the essential ingredients for life itself. A single meteor carried almost no water at all, but this relentless bombardment lasted more than 20 million years. Billions upon billions of impacts gradually released enough water to flow across Earth's newly solidified crust. Though the core still boiled with molten heat, the surface had cooled to about 70–80 degrees Celsius. That created the conditions for the first oceans to form, and for Earth's future stability to take shape. At the time, Earth was trapped in monstrous storms, driven by its rapid rotation. The moon stirred up massive tides that swept across the globe. But as the moon's orbit slowly drifted outward, those tides calmed, and Earth's rotation gradually slowed. Roughly 700 million years after Earth's birth, oceans capable of nurturing life covered the surface. Tiny islands began to rise silently from the vast waters. Lava oozed through cracks in the crust, cooled, and solidified into the earliest volcanic island chains. Over long geological ages, these isolated islands collided and fused together, forming the first outlines of continents. About 3.8 billion years ago, meteor bombardment reached its peak. As they plunged into the oceans, they released cosmic carbon, amino acids, and other building blocks of life into the dark seabed. There, an astonishing city of underwater chimneys appeared. These hydrothermal vents poured out valuable chemicals from Earth's interior, mixing them with what the meteors had delivered. Around these vents, the seawater became a primordial soup, capable of nourishing miracles. Fed by this chemical broth, the first microorganisms, Earth's earliest single-celled life, quietly came into being. But for hundreds of millions of years, life seemed stuck. No new shapes, no complex structures. Single-celled bacteria ruled as the undisputed masters. It was as if the great journey of life was waiting in suspense for a decisive breakthrough. 3.5 billion years ago, in a shallow ancient sea, microbes stacked together to form stromatolites. Here, life unveiled its most magical power. Photosynthesis. They captured sunlight, turned carbon dioxide and water into glucose, and released a byproduct that would transform the planet's fate: oxygen. At first, the oxygen filled the seas. It bonded with iron in the water, forming rust that sank to the seabed, building up rich iron deposits that one day would fuel human civilization. Then, oxygen began to reshape the atmosphere. These ancient microbial mats were creating the very conditions that complex life would need to survive. Over the next 2 billion years, oxygen steadily accumulated. Earth's rotation slowed further. Days stretched to 16 hours. The planet's transformation was long and dramatic. 1.5 billion years ago, the blue planet was dotted with volcanic islands and teeming with primitive life, but still no complex organisms. A great shift was brewing. The crust fractured into vast tectonic plates, driven by convection from the hot core. They drifted slowly, carrying continents and oceans along. After 400 million years, a supercontinent came together. Shallow seas still hosted stromatolites, which kept pumping oxygen into the skies. The air warmed to 30 degrees Celsius. Days lasted 18 hours. The stage seemed set for life to flourish, yet the land remained barren, as desolate as Mars. 750 million years ago, the supercontinent split apart. Mantle heat ripped open the crust. Volcanoes erupted, belching enormous amounts of carbon dioxide. Acid rain scoured the rocks, trapping that carbon deep in the crust. Atmospheric plummeted. The greenhouse effect collapsed. In less than 1,000 years, global temperatures plunged to -50 degrees C. 650 million years ago, ice walls thousands of meters tall rose in South Australia. The reflective ice bounced sunlight back into space, triggering runaway cooling. The ice sheets advanced, until glaciers from the poles met at the equator. A 3-kilometer thick shell of ice entombed the entire planet. Earth became a frozen snowball. For 15 million years, sunlight reflected away, and Earth remained locked in ice. The turning point came when volcanic eruptions kept belching with the ice caps too heavy. Rocks could no longer absorb it. The gas built up in the atmosphere like an insulating blanket. Temperatures climbed. The ice began to melt. The crust rebounded under the released weight, triggering more eruptions. Even more sped up the thaw. Meanwhile, hydrogen peroxide formed by UV light on the ice melted and released oxygen. Earth broke free from its frozen cage, stepping toward rebirth. 600 million years ago, Earth entered a springtime after its icy prison. Days stretched to 22 hours. The abundant waters provided a cradle for life to revive. 540 million years ago, oxygen-rich oceans set the stage for an explosion of life. The seafloor bloomed with early plants, and bizarre armored creatures like Wiwaxia crawled about. They were the pioneers of complex multicellular life. The true stars were the trilobites, ancestors to insects, lobsters, and even scorpions. Life was evolving from tiny microbes into astonishing giants. The anomalocridids, nearly 2 feet long, ruled as apex predators. With compound eyes, sharp jaws, and powerful grasping limbs, they locked onto prey and struck with ease. Tiny Picaia, just a few centimeters long, evolved what may have been the very first primitive backbone, a structure that, over hundreds of millions of years, would give rise to the spine that lets us stand upright. Land appeared, but at 30 degrees sea surface temperatures and oxygen near modern levels, it was still lifeless. Why? Because deadly solar radiation made it impossible for complex ocean life to venture ashore. The solution came from above. Around 50 kilometers high, sunlight interacted with oxygen to form ozone. Gradually, a thick ozone layer developed, a protective shield that absorbed harmful rays. Without this umbrella of ozone, life would never have left the oceans. As radiation threats weakened, land became habitable. Plants flourished first, releasing huge amounts of oxygen and driving its levels higher. The story of life's invasion of land began around 375 million years ago. Strange fish appeared, with heads that could turn, and fins strong enough to support them as they walked. Their descendants, the first 4-limbed vertebrates, gradually adapted to life on land. Over 15 million years of evolution. By 360 million years ago, they had finally made land their permanent home. Forests of ferns 30 meters tall spread wide. Seed plants emerged. Unlike spores, seeds carried embryos protected by nutrients and moisture, able to survive months or years in harsh conditions, waiting for the right moment to grow. These seeds grew into vast forests, continuing to pump oxygen into the air, oxygen that we breathe freely today. But humanity's appearance was still 360 million years away. Giant dragonflies, as large as hawks, took to the skies. These, Meganora, evolved their crawling limbs into wings, extending their hunting range. On land, millipedes, cockroaches, and spiders thrived. As some of the earliest colonizers of land, arthropods had already existed for hundreds of millions of years. They looked strikingly similar to insects we know today, but they were far larger. The oxygen-rich atmosphere supercharged their breathing systems, making such gigantic forms possible. Where there is life, there is death. Over hundreds of millions of years, countless plant remains were buried beneath heavy sedimentary rock. There, under heat and pressure, they transformed into coal. And yet, new life always returned. Sprouts once again painted the land green. By then, life had truly conquered this planet.